Yeah, so I think we can start now. So, yeah. So, hello everyone. Today it's session three of DSA series. So, we'll be talking about matrices and a very introduction to stacks and queues. Both of the things are kind of very important when it comes to a DSA perspective. So, yeah, today's speakers are today we have Charvi who will be explaining the matrix portion, and then followed by Swami will take over, who will be explaining the details about stacks and queues. So, maybe Charvi, you can start.
Yeah. Oh yeah. Can you see screen?
Yeah, yeah, yes, great.
So guys, this is third session of DSA series. Um, so today we'll be discussing about matrices and also followed by stacks and queues. I'll be taking the matrices part. So okay, we'll start. So this is just a very much brief introduction of what exactly a matrix is. You can have matrices are we all know arrays as we have discussed in the previous session. The arrays would be a linear way of storing data in this well, it's just like kind of a list where you just keep storing data in units, and matrices would be having a different multi when you have multi dimensions to this array. So they're also known as multi-dimensional arrays. Yeah, so you can have them n-dimensional, and this is like a general way of declaring how you declare an n-dimensional matrix. And okay, we would be only dealing with two-dimensional arrays for the time being. Mostly we won't be going for the n-dimensional. Mostly it's just two-dimensional. So in when we have it in two-dimensional, we have it as M, like if it's of the format, the data type, the array name, and the X and the Y respectively. Your X would be the number of rows that you're having, and Y would be the number of columns that you'll be having in your matrix. Yeah, so for matrix traversal, yeah, for matrix traversal, you will be having, yeah, so actually I was asking in approaches, guys, for a matrix traversal, maybe just change the screen. Okay, so would anybody mind speaking up? Anyone? Like anybody can just share their views of how we would do a matrix traversal. Maybe yeah, a brute force method.
Going through every row
Okay,
and moving
and
to next column after the completion.
yeah, that's fine. That's perfect. So yeah, so yeah, so just like we discussed. When we have to do it in the brute force method, we'll have it as you go through each row. I mean, if you have like n, if we just consider n into n matrix, we would go to each row and we would traverse through each element and like in column wise. So you get an n. You have to apparently travel n into n elements. So that makes your time complexity go to n square. So there are different ways. Like that's the most brute force. That I mean, that's the brute force method of how you do the traversal. But we can do like using BFS and DFS method also to do that. That is like you use a queue implementation. If it is that's like breadth first search, and then it's a depth first search where you can like you use queue approach in breadth first and stack approach in your depth as implementation. We will not be discussing much about that, but then I, I just want to mention that to you. Yeah, this is just the n square way of implementation. Okay, so this is a question in general. If you have to print elements in a zigzag fashion, how will you do it in a matrix? Any approaches, guys? Okay, so I think I have got this. Yeah, this is what I mean by a zigzag fashion. First, I go for the first element in the first row, then you go for the first element in the second row, then first row, second element, and then you
Yeah,
go.
we since we
The
uh,
current slide is any approaches.
yeah,
Sorry.
The
we'll
s-
switch the slides.
slides are not
The
approaches.
slide is stuck.
Slide is stuck
Yeah,
at 3.
it got stuck at this slide. Any approaches? You just move it a bit.
Okay, just a second. Let me. Okay, just a second. Now is it visible?
Yeah, it's not.
Okay. Yeah, now is it fine? Hello.
Yep.
Yeah,
Yeah,
yeah.
okay. Yeah. Okay. So yeah, this is to yeah. Any approaches, guys? If you have to print elements in zigzag fashion, what would be your approach? Okay, by zigzag, this is what I meant. You first have your, you start like, okay, for this example, I can say it's like 1, you go to 5, you go to 2, and 3, 6, 9. Is my mouse pointer visible?
Uh,
Anyone?
no, the screen again got stuck. You can just see how to print elements in zigzag fashion. Perhaps you can just move to the next slide.
I'm actually in the next slide. Now is it
Yeah,
visible?
yeah, this is fine. Yeah, it's visible.
Okay, I think when I go to the slideshow mode, it's not working. Okay, maybe. It's
You can
okay.
just do a kind of slides kind of thing.
Y- Yeah, like when I'm doing slideshow, I think it's having error. I'll just show it like this.
Yeah, it's fine.
Yeah. Yeah. So yeah, so this is what I meant by zigzag fashion. If we, I mean, first in this, for example, given it will be like you go for first element. I mean, 1, 5, 2, 3, 6, 9, and like so on in a zigzag fashion. So any approaches, guys? How would you traverse this array? I mean, this matrix.
We can use row number as 0 and column number as 0. Start increasing everything by 1 and 1.
Okay. I mean,
If it crosses, not increasing, if it crosses 0 or n, it should be factor. It should be taken as a reminder of that value,
mm-hmm.
and you can do it.
Mm,
Sum of indices of all diagonals is constant.
Sum of.
Indices of all the elements on a diagonal is constant. So we
Yeah,
can
that's one of our precious.
we can set it and then we can loop it according to by setting initial conditions.
Okay, that's one of the approaches. Uh, can you just read what was the previous approach?
It's
What I hello, am I audible?
Yeah, yeah, yeah.
What I said was the
No, no, I
initially.
understood I understood your approach. I wanted the other guy to speak.
Okay.
I was wrong. It will be wrong.
Okay, so can I? Okay, I think I have to move on. Yeah, so uh, the most thing is the property of like this is the approach which I chose to explain. It's like yeah, there are multiple approaches, obviously. Here it's like when given a matrix with n rows and n columns, the number of output, or let's say the number of elements that you put when to that you output in each line, the number of lines that you would get would be m plus n minus m1. Okay, so this one would be like you take the matrix, you visualize it in this way. Uh, just a sec. Yeah, so what I do is just you kind of move the matrix a bit side in the sense that you shift those elements. For example, here I've arranged like 1, 2, 3, 4 button, but then I put 5 like correspondingly. I just shift every correspond down as you go down the row number of as you go down the first column, just shift the one position of the row to the right, and like yeah, I think so you rearrange your matrix like this. Okay, and then okay, I'll just show you the code. Yeah, so here we define a function which is like is valid. This one would be just checking if you have if you're still in your bounds of a matrix, or are you not in but this function is actually you can use it for this is actually good. I would say good practice to keep this function handy is valid, because most of the times when we do matrix traversals we are bound to go out of indices. So it's always good to define this function that is valid, just to see that we are within the limits of your matrix in indices. And yeah, okay, and this one would be just to check the validation. And then you have your diagonal order, that is to be like yeah, so first what do you do, if you can see here in the beginning we have defined your r, I mean this is a C++ syntax, so we define R as 5 and C as 4 as per C++. If you guys are not aware, uh, it's like aliasing. So it's like you're like assigning R is taken as to be 5. Wherever you use R in the code, it's 5. Wherever use C in the code, it's actually 4. That's what it means. So yeah, its valid function will be only to check just as mentioned. And then this one would be your diagonal order, that is you pass the matrix as an argument. That's exactly int array, where you like traverse through the like this is the first you print your first element, and then what you do is you decrement. Yeah, here your the k is okay. I think you guys are aware of the basic C++ syntax. Should I be really focused on that? Okay. Yeah, so here we take your in the row element. R here stands for your number of rows present. So what do? You decrement your row by one. That's I becomes k minus one, and then you set your in. This is like the start first traversal. So yeah, you set your value of j as one, and then you first of all check if you are still in your bounds, and you keep and you print your element present. So it's like you just like in this diagram, you come here, you start with your one, that's your 0, 0 index, You go down to your 5, that is like you actually you go down to the next row, then you go all the way up, and then after you reach the topmost element, that is when your row value goes to 0. Then you move left, and then you come down to your all the way when your column goes to 0. Likewise, you keep toggling this condition, and you print the output. That's the approach. Okay, so this would be your output. And the time complexity for this would be, yeah, number of row into columns. Okay, this is another question. If you're given an n into n matrix, you have to print the numbers present in the matrix in the spiral way.
Yeah, Chavi, just before we start with the question, could you please ask if anyone has any doubt on the previous one?
Okay, so yeah, sorry. Yeah, does anyone have any doubt?
Yeah, any
Hmm.
doubts? If you think you don't understand the solution to this problem, or if you have some better approach.
What advantages does this type of traversal have over the traditional traversal?
Okay, let me answer this question. See, this won't have any advantage when it comes to time complexity or space complexity. Um, of course, I mean, you need to print out number of elements is equals to row into column, so you won't be having any advantage on that. But these kind of traversal questions are kind of important, and specifically when you'll be going to solve some kind of advanced TP problems, or maybe some sort of questions which requires this kind of traversal, this will work in very handy. So diagonal traversal and next is a spiral traversal. Those two are very important, at least for the basics for matrices specifically. Any other queries like you want us to entertain? Anything you couldn't get in the solution, or you can propose a better solution? If not, then I think we can get moving. Yeah, shall we go on?
Yeah, just like so said, these questions are not like I'm not really looking into optimizing these cases. It's just like you have to like in matrices and arrays, we mostly go out of the bounds. That's mostly what happens in issues. So these questions are just to keep you to understand better of the concept. That's what I would say. It's not just like to improve or something. So, guys, in the approaches, like we'll be mostly focusing on what kind of limits do you have to actually set when you have to do such kind of in these questions. Okay, even if we take about the previous question or right now the spiral question, it's thinking about what will be your base case. How would you go for the next? What's your next step, and what are the actual constraints that you're going to set so that you don't go out of the bounds. So, guys, any approaches? Anybody? Yeah, actually, if you're a computer science student, you'll get to face this question in your second year, first sem, in your third sem. You'll be having a course. Okay, so if nobody wants to speak, I'll
Hello.
stop. Oh, hi.
Can you show an example of the spiral traversal?
Okay, I think I've got example. Next slide, just a second. Okay. Yeah, this is what I meant. Given a matrix, 1, 2, 3, 4, like this is the matrix given. My spiral traversal would mean I'll start with the first element, and then I'll go all the way till the last. I mean, to the end, and then like that. Just a way how you do a spiral traversal. I mean, I think the diagram is clear, or should I explain more about? Hello. Hello, am I audible?
Yeah, you're audible.
Ah, okay. Yeah, so is the diagram clear or should I explain?
Yeah, it's clear.
Okay. Yeah, guys. So, in approaches, you can just say something. You don't have to be correct. Like always, you can say it's fine even if it go wrong. Just have. I just want to hear all your approaches. Anyone? Someone please would like to volunteer. Or shall I proceed? Is it like nobody's getting any idea about this, or yes, you can speak up. Okay, I'm fine.
Hello.
Oh yeah.
Yeah, so the if is valid loop will run first. So
Okay.
so after that we will check whether say i's value i's value is say zero. No, like
Okay.
if a's value is zero, it will go from 0 to 3 while I is zero. So after
Okay. So
it
you're
comes,
explaining. Just a second. You just explain me this for this generic question.
yeah, like the algorithm.
Okay. Yeah. 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 Fine. Fine. Go ahead.
Okay, so if whenever it encounters the end, like if I is the end of like n minus 1, where n is the length of the loop. So if
Okay.
I or j is n minus 1, it will just start another loop which will go for the other variable from 0 to n minus 1.
Like okay. Just a second. Okay. In this case, you have your rows and columns same. It need not be that it's okay. Wait. Okay. It's an n into n matrix. Yeah. You can. Yeah. Yeah. Yeah.
Yeah, so basically if I
Uh,
is equal to 0, so from 0 to 3,
Excuse me.
hmm,
Yeah.
Yeah. First thing, one thing is perhaps you're getting it wrong that it's not always going to hit the boundary. It's not always going to be n minus one. See, as we move inside this whole spiral, the thing is getting decreased, and the lengths and the widths are getting decreased. So yeah, it's not always n minus one. So you need to keep a track
so
of that
n,
also.
okay, so I can keep a counter variable like k, so which will do k
Yeah.
minus
So
minus.
don't you think?
Hmm.
Yeah, that's fine. You can keep a lot of counter variables to like counter the thing. This is my current length and this is my current width, and thereby I go. But don't you think it can be done in a much more clutter-free manner?
Okay.
I mean, I don't want this all hassle. I just want a clean, clear answer. When see if you are facing an interview tomorrow, you need to explain this to your interviewer. I mean, during the interview, you already have a tension of the interview, and thereby, like if you want to introduce so much of clutter into the problem, it might be your solution can turn out to be a wrong, or maybe you miss on something. So always just try to be clutter free in your solutions. Just reduce the clutter. Yeah. So can you just think in a like in a very smart way, so that we can incorporate this whole fact. I can give you a hint. You guys have any idea about visited matrix or a kind of a Boolean matrix? It's a matrix which initially all the elements would be false, and once you traverse the matrix, you can turn these falses into truth, and thereby you can have a kind of order that okay, you have already visited this matrix, and then you can proceed. Like it's a kind of a hint. This thing is also possible. You can also create another matrix. Just think and
Can you
smart.
print row by row, column by column?
Like for example, if it is an even matrix, there will always be a starting point which can be represented, which will always have specific coordinates. If it is, for example, an even matrix, the last element would be somewhere which coordinates can be deciphered. Then we begin with right plus one, then up plus one, then left plus two, down plus two, and then we can repeat it. And if it is an order matrix, then we will be entering from the left side. So for that we may have a different algorithm.
So basically, you're kind of hard coding the whole thing, right?
Yes,
Like you're just introducing mathematics to this problem. Yeah, that's fine, but again, you need to do a lot of mathematics
but
to
it
do
will
the
not be
code
efficient.
system out there. Yeah, you can always do that. There's no harm to it. But yeah, there exists something better. I mean, it's much more easier than you normally think. So that's the point. Like you get to learn such algorithms which are kind of easy and like you appreciate those algorithms for sure. So any other approaches before Charlie goes on to the next solution?
Yeah, so, well, I've, like what you guys have given me an approach of setting the limits of starting, ending of the columns, and you keep track of them and you keep traversing. That is like, uh, that's the approach which I have put in today's slides. I didn't want to keep it complex, so yeah. So it's like, just like I've said, you have this spire. You have this. Yeah, I have like in when you have the spiral matrix, you have your row the even like your the starting of the row and your ending of the row. So the important constraints here would be your like the begin of the row would change, begin of the row, or let's say begin of the column would change, your ending would change, and also the order where you traverse. You can either go from left to right, right to left, top to down, and top down to top. So based on that, for that constructs, we actually initialize like four variables that would be monitoring the starting, ending, and we actually put down the cases of how you would traverse. Is it from right to left, left to right, top to down, or down to top? That's what was the approach. But it's very simple of a code. We'll be anyway sharing slides, so yeah, I think I can move on. Any doubts, guys? Should I be explaining this or is it okay? Guys, is it okay? Uh, Hello, am I audible? Am I audible?
Yes, it's okay.
Okay. Okay, I take that. Okay, process one. Yeah, so just as mentioned, today we'll be dealing with the standard template
Just a
library.
minute.
Ah,
Just a minute. I think we got a comment. Manur says, uh, is there a more efficient approach for the service spiral traversal one? Yeah. In terms of efficiency, it's not. But if you want to code it out, then there exists a much better solution. You can just go and search for spiral traversal matrix, and the first GHA link that you get, the very first approach. It's a kind of a very beautiful approach. I personally appreciate it very much because it reduces all such loads of keeping and maintaining variables. So you can just go and have a check, add GHE, and print a given matrix in spiral. The very first approach. Uh, yeah, you can get back to me anytime if you want to like. Yeah, you can get back to me anytime if you just have some doubt in your approach or you couldn't understand, you couldn't get it. But yeah, in terms of coding it out, it would be, I mean, much more beneficial for you guys. Yeah, Chavi, you can continue.
Yeah. Yeah, so today we'll be discussing about the vectors of standard template library in C++. Okay, so just like arrays that we have, arrays are like a continuous units. You have your data stored in a continuous manner. That is, you have them in a continuous manner. Even vectors are the same, but they are like dynamic arrays. Like in the current day, if we like talk about Python language, we can actually resize the existing array. But then when it comes to some like Java, for example, you can't change the array once you declare it. So it is then when vectors are actually a lot handy. Vectors are like, as just as said, they are dynamic arrays and they are able to resize if we are not like, yeah, if we insert an element to increase its size, and if we delete it, it would automatically change its size. You don't have to manually delete it, or you don't have to manually format it. So yeah, and then they're contiguous and they are traversed just like you do. It's all same like an array. All that is it that has its properties that it can change its size by its own. Like once there's no element, it recognizes it and it leaves it. This is how you declare a vector. You have a vector, you have like a keyword, vector, and you have the data type, and you like this is a vector name that you store. In this case, it's like G1. Um, and then when you want to insert data in a vector, it goes to the end, the last element, in a sense. Yeah, it adds as element from the end of the vector. So actually, using vectors, it reduces your time complexity most of the time, and also just because inserting and erasing at the beginning or or in the middle is linear in time. So that's like a brief introduction of what exactly are vectors and why would we would be using it. Yeah, so these things are like the functions of vectors. Your pushback will be to push the elements into the just as I said, we add the elements to the end of the vector. So pushback function is to add the elements from the end, and your pop back would be to remove the elements from the end. And if you guys are like aware, in even when we have arrays in Python, if you use a pop function without an argument of which index you want to delete, it takes the data from the last element. Somewhat like that. And then yeah, insert, just as name suggests, is to insert it where you want at the specified position. It takes the argument as an integer. Erase would be to take off an element from that specified clear, and then you have your, yeah, these functions are to access the element, return a reference to the element at position. This is just like when you do for arrays also, when you can see the element referenced in that particular index if you give the array name and the index number. Your front would return the first element in your vector, and your back would return the last element in your vector. And just as I said, your vectors would resize itself when you perform an operation, let's say insertion or deletion. So your size function would return what's the size of the vector, and your max size would return maximum size, capacity, what is like we have allocated current when we begin the vector. I mean when we initialize it, what is the capacity it can hold. You can resize your vector, also you can empty it. Well, like I mean you can check if it is empty or not. So your begin would be like to point your in a vector. If you have to point to the first element in the vector, then you use the begin function. And if you have to point to the last element, you use the end function. So these are like the generic algorithms that we have. I mean, general algorithms. Like these are the like what do you say? These are inbuilt functions that come along with vectors. Like these are you can use them right away in a program. That is like your sort function. These are the arguments that you have. That is to sort like the arguments, if you can see, it's like the first iteration and the last iteration. That means you, with given a specified position in your vectors, it would sort that particular region, or let's say that particular indices, the values between those indices. So like these are two different types of sort that you have. Then you can reverse your vectors also to find your max element, to find your min element. Then you have accumulate, that will give you a cumulative sum, and your count will be to find this will be the in start index, the end index, and the number that you want to find out. I mean to count the number of occurrences of that particular given value, and your find would be to find if that exists or not. Binary search, it's actually that binary search would work on software vectors. Basically, binary search algorithm is a kind of a sorting algorithm with a uh, time complexity of log n. And then we have the lower bounds and upper bounds of a vector, the properties. Erase would be to erase, ARR would be basically to mean the vector with name to erase, and the two different types of erase function. Then you have your next permutation and previous permutation. Yeah, so this is like a brief introduction of vectors as in standard template language of C++. Any doubts, guys? I mean, from after that we have questions. Some two, we just have two questions to discuss regarding matrices. Uh, Hello, guys, am I audible? Hello, hello, guys. Any doubts or anything you want to ask? Is it
What is the
clear?
use of iterators?
Sorry.
Iterators.
Iterators, they're just to they iterators means you're like just like when you have in your arrays, you have your indices. Here, your iterator would be, I think, do you mean this one? First iterator and last iterator, is that what you meant? These are just those indices, like just like in your arrays, you give your indices. Here you have your first iterator and last iterator. Those are the indices that you provide in the vectors. So from that given indices, it would do this operation. Is that what you meant?
These iterator and indices are same.
Yeah, in vector notation, yes. I mean,
Okay,
in case of vector, not vector notation.
okay, thank you.
Like in the sense uh, they're not exactly your addresses. They are like they point at the memory addresses of your vectors. I mean, They're like somewhat similar to the arrays indices, but then they point to in here when we have in vectors they point to the memory addresses of your standard template libraries containers. That is here it's a vector. They're not exactly same, but then, yeah, they do the same function. Any doubts, guys? Hello, hello, guys. Any
So
doubts?
it basically, works like a list in a like Python.
Yeah, but then here, yeah, basically it's like listen Python, but in Python it's like you have just like the previous question is array indices and iterator. Here in this case same, no, like they are somewhat similar, they do the same function of putting your but here the iterator points to your memory locations. So it's like an object, or let's say it's like a pointer that will point to the element of your vector. Yeah, so more or less the same. Yeah, lists of Python. But then
Yeah.
in Python, when we, yeah, yeah, there's somewhat similar. Any more out guys? Guys, any more doubts? Or we have two questions to look. Can I go with it?
Yes, you can.
Hello? Oh, okay. Okay. So this is your first question. So given a 2D array, you have to find the number of you have to find the row with the maximum number of 1 plus me. So yeah, zero based index would just mean that your first row is taken as 0. It's not 1, it's 0. The index value would be 0. Any approaches, guys?
You can go through the rows, and when you will encounter one, jump to the next row
Mm-hmm.
and count.
Wait. You have to give me that row. It's not like I'm finding the maximum number, right?
Yes.
What did you
We
say?
will set up a
Just a second. Can you repeat? No, I mean, just you said me. You just said that if you see one occurrence of one in a row, you will go to the next row. So I didn't understand that part.
Before that, you will calculate number of zeros or number of columns minus number of zeros to get the number of ones. Next, we'll check the next row. If that is more than the previous row, we'll change the maximum value and we'll iterate it over all the rows.
Uh, I didn't get your approach. Like you just said that in a row you have.
First I'll go to the first row,
Okay.
start traversing the row.
Okay.
If I get a one somewhere,
Okay.
I will store the index of the one as maximum value.
Okay.
Next, I'll go to the next row.
Why? I mean. Okay. Maybe continue.
Then I
Uh,
will use the same process to detect the one.
Oh, okay. So you are okay. You're going for the approach that the array is already sorted. But then it's not that your array will have all the elements or always zero. It's just that in this particular case, it has come out to be like that. Like in a sense, I think you understood what I wanted to say.
No, can you repeat it?
It's like the array is not made up of 0 and 1. It can be any other elements in this question. I mean, this particular
It is a
case, it has
Boolean
come
array,
out.
right?
Uh,
It is a Boolean
Uh,
array.
okay, okay. I mean, okay. Yeah, for this case, yeah, if we, for this case, yes, your approach is correct. I mean, that could work. Um, okay, guys. So if it for a generic case, if it is of other case, like okay, for any other approaches for the same question. Okay,
We
I can
can
also.
set up a counter while also
Mm-hmm.
keeping max is equal to 0. So
Mm-hmm.
whenever the counter c is like greater than max, we are going to store
Mm-hmm.
the index value. So when the whole loop runs, we can just print the value of index which has been stored.
So you basically count the number of occurrences of
Yes,
ones in each row.
yes.
Okay, that's a brute force method. Yeah, that's fine. But then what happens when a brute force method is time complexity increases because you're actually traversing. It goes to O n square. Your
Yeah,
approach
yeah.
goes to O n
Two,
square. Okay.
yeah, two for loops would be used. So
Yeah,
one.
yeah, yeah. Oh, yeah. So even in the previous case,
So we have to solve
you
it in
have
ON time.
yeah, like you optimize your case. Yeah, like you optimize your answer. So like, if you have a better approach, you can go for that, right? Guys, the important point here comes to be okay. So I just want to change this question slightly differently. If let's say I'm not taking a Boolean matrix, I'm just taking a matrix in general, but then it is a sorted matrix. So here your catch point would be that the each row is sorted. So what do you think? Okay, in a Boolean approach, if it's a Boolean matrix, I think one of the approaches we're given were is totally fine. That you just go for the element where you have to store it and use it. But then if it is not a Boolean matrix, and if my each row of my matrix is sorted, then what is the catch? Like we had this discussed in one of our CP sessions of what is importance of having elements sorted, or if a question comes out, what is actually important? Why should the first thought be to sort your elements first? Any approaches, guys? I've changed
Uh,
the
can
question
we
slightly. Yeah.
can we do a column traversal while keeping a counter k? So that whenever it counters a one, like the first time
Mm-hmm.
it gets a one, so
Mm-hmm.
that would be our index where it has the maximum number of ones.
Like yeah, you don't count it, but then you go with yeah. It's somewhat similar to the previous approach that was given. They've said that you go through each row and then you check out when is your first one encountering, and then you go through all those all rows and see if it is of higher index or lower index and change accordingly. I think the both the approaches are somewhat similar, and yeah, I think both of them would come out to be the of the same kind of complexity. Yeah, right. Like in your previous your approach is totally fine. Now I'm asking a different question. What if my array, or let's say, what if my matrix is not a Boolean matrix? I'm not talking about a Boolean matrix. It's just a matrix in general. And my matrix has having each row sorted. Any approaches, guys? It's fine if you even if it goes wrong. I mean, it's an attempt. What if my matrix is not a Boolean matrix? I think I have the code in the next slide, but then the code is not that much of a priority. It's about the approach that you want to use. Guys, anyone? Okay, just think of searching techniques. Anyway, is there an efficient way? Let's just don't think about it matrix. Think about like when you are talking about each row in a matrix, it's apparently just an array. So, is there an efficient way how you traverse an array which is sorted, guys? Any ideas? How do you traverse an array which is sorted? That is your question. Any approaches? Have you guys heard of? I think nobody wants to say anything, so I think I should be telling. Okay, I think I'll tell. Okay, so in this we have anybody of you heard about binary search? Binary search algorithm? Anyone? Okay,
where we
so
have to take mid
yeah.
element and
Yes, exactly.
yes,
Yeah, yeah. So you use the binary search algorithm. So for people who don't know what it is, binary search algorithm would be to take you take your array, which is sorted. It only works on a sorted array. You take your array which is sorted. You have two pointers. That one pointer would point to the beginning of the beginning of the array. Another one would be to the end of the array. You find the median element. You find the median index, and also then you access the median element. And if the element that you want to find out or you're looking for is lesser than, first of all, we check if it is equal to the median element. If it is, then that's your answer. If it is not, if it is lesser than, you look at the left side of your array, right? I don't have a screen right now. Like I don't have the thing. I think you guys are getting what I'm telling. Is it okay, or should I actually try explaining it on the board or something? Hello, guys. Hello. Am I audible? Anyone? Am I audible?
Yes.
Okay. So in your array, okay. So what I was saying is, when you have an array, you have two pointers. Where one would point to the beginning of the array, and one would point to the end. You find your median element. If the element that you have to find is equal to your median element, then you get your answer right away. Or then you check if then you check if it is lesser than your median element, or if it is greater than your median element. I mean, obviously, but when you compare two numbers, all you have is these three cases. So when you are going for, if it is lesser than, then you're looking for your answer in only in the first half of your array. If it is greater element, you're looking at the second half of your array. So what you do, the change that you do is, if your element is lesser, then you bring the high value, let's say low and high. They are the pointers that point to the first element and the last elements. What you do, if your element is lesser than your median value of the median element, then you bring your high value, the pointer that points to the last element would point to your m minus the median element minus 1, or maybe median element, like, okay, you can use any notation. That basically means that you're looking your answer in the first half. Else, if it is a greater element that you're looking for, then you shift your low value. You set that low pointer to the pointing to the median, to the median element. So now you have changed your what do you say, the space that you're looking. You're not checking through the entire. You have deleted half of your array right away. Do you actually want to check that out or not? So that has reduced. So like that, you keep repeating this process, and finally, if your high goes lesser than your low, or if it goes in a weird condition, that means that you haven't found your element. Or if the element is there, then you get an answer in a log and time complexity. So is that clear? So that exactly is the better approach of doing this. It's not a matrix question. It's about an array question of how would you find the element in your array.
Uh,
So this is
Charlie,
actually,
one thing I would like to add. Can you go to the 21st slide again?
yeah.
Okay, so the binary search approach will be, yeah, it will be optimized one, but since here the array is a boolean array, and it is a row wise sorted array, row wise sorted array also. There is a there is one more approach to solve this problem. What we can do is, we will start from the rightmost index in the first row. uh, Suppose 0 1 1 1, and the last one is that we will start from there uh, till we find 1 in the first row. We will move towards the left, and when 0 arises, we will move downwards. And uh, and suppose we found a 0 over here, then we will move again downwards. If we found a 1 over here, then we will move to the left again. uh, are you guys getting it? Suppose I traverse from the last element in the first row. I will move to the first index, then I will move downwards in the second row, first index. I will see that 0 is there, so I will not move to the left. What I will do, I will move to the downside, and in the third row, again I will follow the same pattern. I will move to the left as 1 has occurred, and I will keep a max index counter, which will help me to see whether which row has the left shift of the pointer. And whenever no more left shift is not possible, then I will return that pointer. So the time complexity of the binary search algorithm will be, uh, suppose m columns and n rows, so it will be m log m, but the time complexity of this approach will be O of n plus m, because we are only traversing in a one direction and in a bottom direction. So it will be like O of n plus m. Of course, both of them will have a approx same time complexity, but since here the matrix is row wise sorted, here we have that additional advantage of just traversing, and binary search is not needed. uh, Hope you guys got it. Hello.
Yeah. Guys, any doubts? Hello, guys, any doubts you can ask? Is it clear what he has to say?
Okay.
Yes.
Is
Okay.
it okay? It does. Okay, fine. So the next question would be, yeah, this is to find the common elements present in. Yeah, you have to find the common elements present in the matrix, which is there in each row by just one time traversing your matrix. So here in the question, it's strictly given that you can't have your time complexity crossed, like you can't have own square. It's direct. Like guys, you can use the just like a hint. I wanna say
Um,
you guys can use the approach he has given, or like wait.
okay.
Yes.
So any approaches for this problem? Any brute force approach?
Brute force approach would take it to n square. So
Of
n square because
uh,
we
of
take each element and then check it with all other rows. So that
we
would be
take
n square.
each element and check it with all the other rows, so the time complexity will be
N
uh,
square.
I think it will be like O of m square into n square, right? uh,
Hmm.
yeah, okay. Because we are taking the each element, and we are like the normal searching in a double for loop. Instead of double for loop, the double for loop on a double for loop matrix, so O of m square into n square. uh, but the other approach over here is that have you guys heard of the data structure hash map?
Uh, hmm.
Hmm?
Let's have an idea of.
Acha, okay. uh, so if you guys know of the data structure hash map, then the problem becomes very easier, because what we just have to do is
It's
just
by this one. Like the first thing that you would be doing here to sort your the elements in your row, like, and do your binary search. But then to do your binary search in even more efficient manner, the better you have to use your maps. And yeah, by you can
yes,
continue.
yeah, suppose you used a binary search approach, then the time complexity will be like you are sorting the each row of the whole matrix. So uh, you're sorting each row, which turns out to be n log n, and since you're sorting each row in the whole matrix, the time complexity will be like n into m into log m, or the it depends on what you consider as the row number and what you consider as the column number, but it will be like nm into log of something. The more better approach is, suppose we use a hash map over here. The the thing that hash map does for us is that the anything that is stored inside a hash map, or a unordered map, or we just call it a map, is accessed in O of 1 time. Suppose I put up 1 and 2 elements, or suppose 1 2 3 elements, and I want to access the second element, then I can access it in O of 1 time. It is like a the we put elements inside a map in a pair. Suppose like 1 and 2, these both are pairs. So suppose 1 2 and 2 3 are pairs. Suppose I access 2, then from 2 I can get 3, the corresponding element. It is like a key value pairs are there inside a map which we can put and access them. Okay, so you can look at this print common elements function, right? Here we have declared a map. Okay, and what we are doing is, first of all we are traversing through the first row, and we are traversing through the first row, and we are storing the key value pairs inside the map. The key value as the value in the row, and the key as the value in the row, and the corresponding value as 1. Suppose then what does this mean? That we are storing the like the counter of each element inside the map is 1 initially. Suppose some elements are there 1 2 3 4, then the counter of each element will be 1. So I will store the elements in this form 1, and the value will be 1, the key will be 2, and the value will be 1 in this form. Then what I will do is I will traverse through traverse through all the other rows. Okay, I will traverse through all the other rows, and I will check whether the value of the value of the element is present or not. And if the value of the element is present, what does this mean? If map of I comma j is equal to I, what does this mean? Suppose the one element is present in the first row, and it is also present in the second row, then the value of the element will be equal to I, right? So what we do is we increase its value to I plus 1, and at last what we do is just checking through the first row, or maybe the last row, any row, checking whether it's uh, the corresponding counter value is m. So basically what we are doing is uh, we are putting the values in a map for the first row, and then we are traversing through each row. And if the suppose I'm in the third row, and the value of the element is suppose 2, then what I will do, I will increase, and it is also present in the third row, then I will increase the uh, value of the element in the map to 3. So at the last, what I will have is that the element which is present in all the rows of the map will have the value in the key value pair, the value equal to the row number, which will be equal to m. And then if it has value equal to m, then I will just print it. So basically this is the logic. Any doubts? uh, hello,
Or
No,
no?
yeah.
uh, any doubts? uh, if you don't know what is map, then you can just leave this problem. Or else if you know map, then you can just consider it as a alternative for binary search, because binary search has a time complexity of O of log n. It just minimizes it to O of 1, as each element can be accessed in O of 1 time. So in the first approach we were just sorting it, and then we were doing binary search. In this approach what we are doing is we are storing it in a map, and then we are accessing it. We are just accessing it and checking whether the count in the previous rows was equal to the uh, I minus 1 or I, the index, and then we are increasing it. And at the last what we are doing is we are checking whether the counter value is equal to the row number. If the counter value is equal to the row number, then that is the element uh, that is present in all the rows. So we are printing it. Any doubts?
Guys, is it right? If it's fine, I think we can start with stacks and queues part of it.
Mm, okay, so I will consider that you got the algorithm. Okay, let's start with stacks.
Ah, okay. Thank you, guys.
Yeah. Um, uh, are you can you see my screen? Hello.
Yeah, it's like it's dark and black,
Dark and black. Yes.
not visible.
Not visible. Can you see? Can you see anything, or you are just seeing black?
Yeah, it's still black.
Damn, damn, damn. I don't know why it is black. I think. Let me see whether I can share a window. Can you see this window? Hello.
Yes, yes, yes.
Uh, can you see PowerPoint?
I can see gigs for gigs.
You can see gigs for gigs, but actually, okay, just one second. Still, you can't see. Mm-hmm. Damn it. Uh, okay. Anyone knows? Uh, I think I will need to upload the slides to um Chrome for for that.
Maybe you can download the slides or like you can share the entire screen.
No, actually, I'm not able to share the entire screen. It is just showing me that you can share a window, and else it is showing me blank.
Okay, so probably you can download your.
1 second. Can you see the slides now? Hello.
Yeah, yes, yes.
Okay, yeah. Um, okay. Okay. Uh, Coming to stacks and queues. Uh, these pictures that I have shown over here, the first picture, um, which has the pile of pile of the what we say, the plates one over each other, uh, and the second picture, which consider of people standing in a line. The idea behind the stacks and queues data structure is quite similar to these uh, two two pictures. Will I be able to print it, or will I have to do it in the same way? Acha, okay, I'm able to print. Okay, yeah. Hope you are able to see the slides. Hello, hello. Are you able to?
Yeah, we can see.
Okay, yeah. So coming to the stacks, stack is a data structure which has the elements arranged in this form. The form means like the elements are arranged one above the other. Uh, Either you can consider it similar to the pile of books which are kept one above the other, or a pile of plates kept one above the other. Uh, the 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 uniqueness of this data structure is that uh, uniqueness of this data structure is that if we consider a pile of books, or we consider a pile of plates, then we can access the elements only from the top, and not from anywhere else, right? Suppose I want to access the second red book, so I can access it only after I remove the green book, and then I can access it. Or if you are saying that I can access the uh, orange book directly from this point, then you can consider this whole book set stored inside a glass jar. Then you are not able to access it from this side, right? So you will have only access from the upside. So the stack data structure is very similar to this case. Or if you want to access the plate, then suppose you want to access the second plate, then you will have to remove the first plate, and then you will have to remove the second plate. So stack is very similar to this case. Stack is a linear data structure, and it don't consider of any multidimensional form. It is always a linear data structure. And the operations that we can do on the stack is like we can push a element on a stack. Suppose we consider a pile of books, then what operations we can do on it? We can put a uh, put a book on the pile of already present books. Or what we can do is we can remove the existing book from the pile of books. These two operations we can do. Along with these two operations, one more operation stack allows is that looking at the uppermost book. If we consider a pile of books, then if we look from the upper side, we are not able to access or look at the other books. We can only look at the book that is at the top, right? So in the stack data structure also we can only look at the look means we can access the uppermost element, we can push the element on the uppermost element, or we can remove the element from the uppermost element. These are the three operations. Push means place the element on the stack. Pick means just take that element and uh, just access it, like suppose access it without removing it. And pop means uh, take that element and remove it from the stack. So these are the three operations that we can do on a stack. Stack is a last in first out data structure. What does this mean is that in the inside a stack, the element that we put in the last, suppose I put first 1, then I put 2, then I put 3, then the element that is put in the last time will be accessed first. The element that is that we put in the first time, it will be accessed at the last time, as it will be at the bottom of the stack. Okay, so some of the applications of stack. um, Program execution. If we look at the program execution, any program, any program that we have, suppose suppose any program int main, then the parenthesis and etc etc. The working of the program is in the following way. When if we consider, suppose I want to ask one question. If I declare a int a is equal to 5 inside a while loop, and I want to access that a variable outside that while loop, will I be able to access it? um, did you get my question? Hello?
Can you repeat it?
Yes. uh, Suppose um, there is a while loop inside a program. Suppose while n minus minus greater than 0, uh, and and uh, and and there is a variable a inside that while loop. Can I access that variable outside that while loop? Suppose after the completion of the while loop, can I access that variable outside the while loop?
The A has been initialized inside the while loop.
Yes.
Or no?
Yeah. So the way compiler checks whether the variable is present inside the while loop or if it is present outside the while loop. uh, I'm talking about Java. So in Java, the way compiler looks is in this way. Suppose while is declared, or any block is declared, we call it as a block. Suppose while and the while till its end, it is as a block. So when a new block is declared, what we do is we put all the variables and all the things that are present inside a block on a stack. So so the suppose while loop starts and a variable is declared, the a variable will be present in the top of the stack, which contains that information. And when the while loop completes, that top of the stack will be removed from the stack. So it will be removed for the case when the variable is accessed below the while loop, outside the while loop. So when the variable a will be accessed outside the while loop, it will be not present in the stack. As it will not be present on the stack, the compiler will show an error. So in this way it works in Java. Okay, so these are some of the applications of stacks. Program execution, the way program executes the curly brackets, and it also helps in evaluating the uh, different types of expressions, the postfix to infix and all that. Okay, so now you people will have a doubt. So what we are doing is we are having a stack, and we are removing elements one by one from this stack. Okay, and suppose there will be some point when the elements end, right? So what it will do in that case, that when the stack is empty and it don't have any element, it will show an exception that the stack is empty. Suppose in Java it shows java.util.empty stack exception. Okay, uh, now we will look at the implementation of stack um, using an array and using an linked list. uh, okay, can you uh, can you think of a implementation of stack using using an using an array? Any idea how we can implement a stack using an array? Any idea? Hello. uh, okay, so stack stack can be implemented using a array in this way. Suppose I consider a stack in this manner. Suppose I put 1 inside it first, then I put a 2 inside it second, then I put a 3, then I put a 4. What I can do is I can assume this structure in a in a horizontal way, in the way arrays are built. So and I will have a top variable. So when I put 1 inside it, the top variable will be on 1. When I put 2 inside it, then the top variable will be at 2. And when I put 3, then it will be at 3, and it will keep on growing. And suppose I want to remove this 3, then what I will do is I will just change this value to something else. Suppose I change it to, let's say, -1, and then what I will do is I will decrease this top variable to top minus minus. So in this way I can implement the stack data structure using an array. Any doubts? Hello.
Well,
Sorry. Any doubts?
it's good. It's clear.
What?
It's clear.
Okay, yeah. Yeah, this was about stack implementation using an array. If we consider the stack implementation using the linked list, so in the linked list, do you guys know about the linked list? Hello. Do you guys know about the linked list? uh, okay, I will consider that uh, you know about the linked list. Okay, I will give a brief introduction. The linked list is a data structure which is similar to, I will not say array, it is a linear data structure. So it is similar to a vector, or we can say a list, as a it has a, it is dynamical and we can change its size. So we can consider it similar to array list, not exactly, but in some sense. So inside a linked list, what we have is that we have a start pointer, or maybe a pointer at a last also sometimes. But in this case, what we will have, to implement the linked list as a stack, what we will have, we will have a start pointer. Okay, and suppose I want to push an element to the stack. What I can do is I will add the element next to the start pointer. So what I will do is I will add an element next to the start pointer, and uh, I will change the value of this next to the first element. This is about the push operation. Any doubts? Uh, can you repeat? It was not clear. Hello.
It's okay.
Yeah, and suppose I want to pop an element from the stack. Then in that case, what I will do is I will initialize this pointer. This pointer is there, right? This pointer to the this element. If I want to delete this element, what I will do is I will take this pointer and I will move it to this element. So what I am doing is I am removing the reference to this element, and I will also delete this pointer. So I will delete the reference to this element, and in a way the element will be deleted. So for pushing an element to the stack, what I will do is I will bring that element, and I will take this pointer, and I will take this pointer and put it to that element wherever it is. I will put it to the that element, and I will change the next value of that element to this first element. And when I want to delete it, what I will do is I will take this pointer and I will again push it to this element, and I will delete this pointer. So in this way the element will be deleted. uh, when I want to pop it, hello, in routes, when I want to push it, I will take this pointer and I will put the new element, and the next pointer will be to the first element. And when I want to pop it, I will take this pointer and I will put it to the first element, and I will delete this. Any doubts?
Yeah, it's clear.
Okay. Okay, so some of the applications of stack. uh, uh, if you are given a string, can you give me an algorithm to reverse it? Hello. It's very simple, right? I have gave you a string, and I want the characters of the string to be reversed. In one way, I want hello to be converted to this OLLEH. Can you give me a algorithm?
So, like, if we start from the first of the letter of first letter of the word, we just have to push it into the stack.
Okay.
So at the last, like whenever the whole word is completely into the stack, then just have to pop it out. So when we pop it out, as it is leaf O, it starts from the last letter of the word. So hence we can just reverse it.
Yeah, yeah. Okay. Any other way? This is a clear way using a stack. Without using a stack, do you know about any way without using a stack?
Like you mean, suppose if it is a string itself, then we have the you can use the character, right? So you
Hmm.
just have to use the indices from the like indices, and then from the last letter onwards, we can just have to print it by decreasing its value to the initial letter, like the start of the word. I mean,
Just to make a little better, what I can do is the approach that you told me will traverse the whole array once, right? Right.
yes.
To make a little better, what I will do is I will keep a pointer on the first element, a pointer on the last element, and I will keep on reversing it till the pointers don't cross each other. So I keep on swapping O with H, L with E with L, and the uh, pointers will be equal, so I will not swap over here. So in this case the time complexity will be O of n by 2.
But like, what do you mean by swapping?
Swapping,
So
uh,
yes, yes.
swapping means like changing the value of the element. So in the first index, the value of element in the first and the last element will be swapped, means the value which is present at the first index will be present at the last index, and the value which is present at the last index will be present at the first index.
Uh, but in that case, even if we swap it, but how can we, like, if we just want to print it, how does it help us? Help us?
To print the to no To print it, what I can do is I can print it at the very last. First I will swap it and store it in the same string, and at the last I will print the whole string, not
Okay,
character
okay,
wise.
I understood, I understood. So with the same string itself, we're just swapping,
Ha, yes.
so that and at the point where we reach the middle point, then we just have to stop
Ha,
the
ha.
swapping thing and just have to print the whole word. Okay, got it. Okay, yeah,
Yeah.
off and do. I understood. Thank you.
Ha, yeah. Okay, so we can use a stack to reverse the word. Okay. uh, this is a very famous problem, which requires the application of a stack. Suppose I am given a set of brackets. We call it parentheses. Any type of brackets, this type of brackets or this type of brackets, or maybe invalid brackets, something like this. And I want to tell whether the these brackets are balanced or not. Any algorithm, any approach. I am given.
So, 1 minute. So, like, you just have to keep a counter for the different types of brackets. I mean, specifically, I should say a right bracket counter and a left bracket
Okay.
counter. I mean,
Okay.
for all the different types.
Hmm.
So that when we like, we'll start from the end of the, let's say this is a string, and if we start from the end of the string, if we just put the each and every character into the stack,
Okay.
so whenever we encounter a like if it is invalid, then I'm sure that my left bracket number will be more than the right bracket, right? So
Uh,
if right, did you understand? Like,
so what you are saying? I will traverse from the back side. Okay.
yes, yes.
I will
So
put the number on the stack, or
it's like, suppose I have this is a flower bracket. Let's take the last example.
okay.
But
Okay.
so if we like, so right bracket, so I'm assuming there is a variable which is named flower right bracket. I mean,
Okay.
right.
Okay. Hmm.
So I will put it in the stack from the last, right? So when we put it, like, this one increases the right bracket once to +1, again +1, again +1, and now it's a left bracket, right? So after three pluses, so it's a left bracket. So again it decreases basically the right bracket ones, because it's like we found a pair, so that's nice. So it decreases the value. Uh, so at the last minute, our whatever the variables are there, the values in them should be zero. If
Okay.
it has to be
So you are not using stack over here. What are you using stack for? You can just keep a counter and do it in the without a stack, right?
okay, well, in such case, okay, 1 minute. Well, I have an algorithm, but I just can't put it in the words. Maybe I can
Okay.
put
Okay.
it like this.
Hmm.
Suppose if I have a right bracket,
Okay.
the next from the right, I mean, I'm taking starting from the last.
Hmm.
So I'm putting it in the stack. If
Okay.
it's a right bracket, then obviously the above one should be a uh, what can I say? The obviously the above the next element that should be in the stack should be either it's a left bracket one or in another right bracket one, right?
Yeah. 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 Correct.
So yeah, so if it is the case, then Okay. So like, so it always includes it. Okay. Well, I just can't say it in words, but okay. I think I know like at least the way. Maybe you can say put it in the words. Like you
Uh,
can just explain it.
okay, one doubt. Suppose this bracket is there, right? Can you can you see the mouse pointer?
Yeah, I can see.
Okay, suppose this bracket I put it over here and this bracket over here. So this index has a left bracket and not a right bracket. So it will be a invalid parenthesis, right? But
Uh, I mean, but uh, it. Okay, okay. Yes, yeah, you're correct. Yes.
yeah, in that case, it will be invalid, but your program will show it as a valid parenthesis, right?
Yes, yes.
Yes. Okay. So for this type of problems which has a valid means like we have to check whether the brackets are balanced or not. What we do is we use a stack data structure. Suppose let's consider this example. Okay, this all the three types of brackets are present in this, and this is a valid 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 brackets are present. So what I will do is I will put the first element to the stack, second element to the stack, third element. If the brackets are the left side brackets, then I will put them on the stack. Okay, so this is the left bracket, so I will put it on the stack. This is also left bracket, I will put it on the stack. This is also left bracket, I will put it on a stack. This is also left bracket, I will put it on a stack. uh, if it is a right bracket, then what I will do is uh, if the pairs are matched. Suppose uh, this is a bracket of type flower, we call it flower, and this is also a type flower, then I will pop the element from the stack.
Yeah. Okay.
Similarly, see, this element got popped, this element from here it got popped, right? So the next element that is present, it is the this element. So next time I visit this element, and again this will get popped. uh, Again this element, it since it is a left bracket, it will be pushed on the stack.
So at the last, basically, we should our stack should be empty. That's it.
Yes, yes, yes. At the last, our if our stack is empty at the last, then we can conclude that the brackets are balanced, and if it is not empty, then we can conclude that the brackets are not balanced.
Yes. Okay. Yes, fine. Understood.
Yeah. Okay. uh, okay. Okay. So some of the questions. Okay. Some of the questions I would like to take. So this was the first question, right? Valid parenthesis. The second question is this question. Uh, can you see the question? Hello.
Yes, ma'am.
Yeah. So in this question, what they have asked is we are given a string, and we are asked to find the bracket numbers. So suppose this is the first bracket, then this is the second bracket, then this is the third bracket, uh, then this is the means like the corresponding bracket number. So I what we can do is any approaches for this problem. Hope you got the problem.
Yeah. So like it's the same as the previous one, except like in the stack itself, I can put an hash map maybe so that for each how can I say this? Yes. Like whenever we encounter the suppose the left bracket and it's closed again, then it will just print it. Okay. I mean that whenever it encounters the left and right bracket. Okay. Well.
Yeah.
Yeah.
Your approach is correct. Suppose yeah, we can use a hash map also. or else what we can do is we can keep a counter variable. Maybe uh, the counter value will increase when I get a left bracket, and it will be same when I get a right bracket. When I get a left bracket, it will increase. So in that way, suppose my counter variable a is equal to 1 initially, then what I will do is I will print either, or this is similar to the vector inside the C++ array list. Okay, what I will do is I will store it inside the vector. So initially one will be stored inside the vector, and I will increase that counter value to 2. Then again I found a left bracket, then I will increase that counter value to 3, and I will store the 2 value to the array list or a vector. Okay, when I found the right bracket, I will print.
I think we're gonna have this like the type is just parentheses, right? There won't be any flower brackets, and
Yeah,
so
yeah, yeah.
as long as the question like it only contains with that, whenever we encounter the left bracket, we just have to increase it, and like we can also print it. And whenever we encounter the left bracket, we can keep an counter for the left bracket and just print the number. That's it,
Yeah,
right?
yeah. Suppose I think, but I think we will need a map also, because suppose I get a right bracket, then I should know which corresponding bracket it is, right?
Yes, yes.
For that, I think we will need a map also. Okay. Yeah. Yes, we will need a map. So using the map, we will suppose using the map we will find what is the corresponding element.
Yeah, yeah, I understood. Right. Okay.
Yeah. While printing this too, while printing the right
I
bracket
mean,
number.
it's like in the previous question itself, but in because it's like the right bracket and the left bracket they just vanish, right? Whenever in the previous question if it encounters a right bracket,
Huh, huh.
so it's because of which left bracket it's vanishing. That number it has to be there for the right
Ah,
number,
yes, yes, yes,
and we
yes,
can just store it in the in terms of hash. That's it. Okay,
yes,
understood.
yes. Yeah. Uh, okay. So this was the second problem. Um okay. Coming to the queue, let's talk about the queue. Okay. So hope you got about the stack. The second data structure is the queue data structure. Suppose these people are standing in a queue, right? Or anything. Suppose the students are standing in a mess. So when will a task get completed, or when what exactly happens inside the line which is present inside the mesh? The elements get out from the front side, and the elements get inserted from the back side, right? Inside, if they are standing inside a mesh, or any suppose they are standing inside airport, so what will happen? The new element will come from the back side, and the elements which are present from the front, they can be removed, right?
Yes, yes.
Yeah, so the queue data structure is very similar to this kind of structure, which has the removal point from the front, and the insertion point from the back. So this is the queue data structure. Um, Suppose a line in a supermarket. It can be inserted only at the one end. Mostly it is a back end, we call it, or we can reverse the ends of the queue, and we can just reverse the ends of the queue. And it is also a linear data structure. It is not a multi-dimensional data structure in at any time. It is always a linear data structure. uh, so the mainly two operations that we do on a queue are in queue, that we call that we remove from the sorry we insert from the back side, and the dq that we remove from the front side. So two uh, these are the two functions, or operations that we can do on a queue. Okay. Queue is first in first out data structure. When we discuss about the stack, the element which was inserted at the last time, it was removed first, and the element which was inserted first, it was removed at the last, right? But in a queue, it is opposite. The element which gets inserted first, it will it will be removed first, and the element which is inside at the last, it will be removed at the last only. So the scenario is very similar to the people standing in a row. The elements will be removed from the first, and it will be inserted from the back. The person which is standing at the first will complete his task first, and the remaining elements will then be removed from the queue. So some of the applications of the queue, if you are in the third year, then you will know about this round robin uh, scheduling in the operating system course. uh, it is basically an algorithm where a queue is used, and the processes are put inside a queue, and they are put using the first in first out approach. Means like the process which was put first, it will be removed first, and the process which was put later, it will be removed later. uh, yeah. Can you think of any approach where array is used for a queue? In any way, can you think of any approach where array can be used for a queue? Anything? Hello. Hello.
Like in stack, because we restrict that usage of element, like only the first. You can either, it's like LIFO, right? You last and
Okay.
first.
The in the case of this stack, the benefit was that the insertion point and the removal point was the same, right? That was the benefit when we talked about the stack implementation using array. Because the removal point and the insertion point was the same. uh, we had just a single variable to manage, the top variable, which we were just increasing and just decreasing. But in the case of a queue, since the insertion point and the removal point, both of them are different, what we will do is we will keep two different variables, one for the front and one for the back. Suppose these are two different uh, implementations of queue. Both of them are very similar, but slight difference is present. Suppose I kept a head and a tail variable on the first element, then I put 27, and then I put some elements 19, 17, 7. So what I will do is, when I put a new element to the queue, then what I will do is I will increment the tail pointer. So the tail pointer will be to the element which is next to the last element, 7. So it will point to the fourth position. And when I want to decrement, what I will do is I will just shift this head pointer. So this head will shift to 19, then it will shift to, suppose I want to remove 19, then it will shift to 17. If I want to remove 17, then it will shift to 7, and in this way. uh, Rather than moving the head, what we can do is, the in the other approach, instead of moving the head, we can keep the head fixed, and we can shift all the elements to the first. Means like we can shift all the elements by one position after every removal from the queue, after every dequeue operation. Any doubts?
No.
Yeah. This was about the implementation using array. Using a linked list also, it is more simpler than array also, because what we can do is we can keep a pointer to the first variable and a pointer to the last variable. Suppose I want to insert 30, then what I will do is, since it is a queue, then the 30 will get inserted from the backside, right? So what I will do is, this rear pointer, it will shift to this 30, and the next pointer of this 30 will shift to this 30. So in this way it will get inserted. And if I want to remove an element from a queue, then what I can do is I can just delete this pointer from here, and I can shift this front pointer to this next element. So the this element will be removed, and the front pointer will be pointing to the second element, and in this way the first position of this means like the first position of the queue will be removed, and we can continue the process of other process for other elements also. Any doubts? Any small doubt? Okay. Okay. So let's come to some questions. This is one of the questions. Suppose we are given an array, and what we want to do is we want to reverse first k elements of that array. Suppose this is an array 1 2 3 4 5, and I want to reverse the three elements of this array. How can I reverse these elements? uh, any algorithm? Hello.
Like we can use stack directly, maybe y2. Okay.
Okay.
Like
You will use a stack, then
I, I
you will.
mean, like by so for the first. Okay. I mean, there's no point of using this. Like we can just directly start from k minus one and print it, and then again for the k plus one to n, you can just print it. But like, is there an advantage for using q in here? Like, is the time complexity decreased in this?
uh, Not in a way. The time complexity, okay, the yeah, no, the time complexity don't decrease, yeah.
Okay, so
Yeah, there are many ways to do this, yeah. Yeah. So one way, you're using a stack over here, right?
like yeah, for the first k elements, we can just directly use the stack.
Okay.
Like started from the first, we just put the each element in the stack, and then again at the last, we just have to pop the amount, like
Okay,
from the.
till over here, you will use a stack, and then you will again put it to the elements. Okay, yeah, right. Am I
Yes,
right?
right.
Yeah, this is one of the approach. Can Okay, okay. The question over here is, we are given a queue of integers, not an array of integers. Okay.
Okay, okay. So okay, they're in the form of queue, like
Yes, yes. They are already given. Means like this 1, 2, 3, 4, 5 are not inserted in an array. They are inserted in an queue.
okay, you mean like the first the one element is present, like it was the first element which is pushed into the queue, right?
Yeah, 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 yeah.
Okay, in that way. Well, like it would be then.
Any approach?
Well, until I reach the number, like like I'll keep a value variable. So I will just what are the first k elements are there, I'll push them into a let's say again a stack, and then
Okay.
again I'll print them, and then remaining elements in the queue I will directly print them out.
Yeah, actually, yes, the approach is very similar. What you can do is you can take the first k elements, push them to the stack, then you can use a different queue, push this element to the front of the queue, and then after that you can push these elements to the back of the queue.
Yes, right. Okay.
Yeah. Okay. Some more questions. Okay. So I missed some stack questions due to the slide problem. I don't know. This is one of the stack question. We are given a string and we want to reverse each word inside a string. Suppose I like this program very much, and it should be like this then. Um, you got the problem?
Yeah, understood. So so it's like okay. Suppose if I encounter a, let's say I'll put each and every letter into the stack. Suppose if I encounter a dot, then I'll start popping them out again.
Hmm. Yeah.
So that popping in the sense I'll print them out by removing them from the stack. That's it.
Okay. Do you think any different approach than a stack?
Um, well, I mean, different approach by in the sense only by using stack and then different
No,
approach or a different data structure.
without using a stack.
Okay, without using. Well, you can use a two pointer thing,
Two pointers. Yeah.
but two pointers again they take much time. Well, like, do you want me to think any for like with a more efficient algorithm, or you just want to try with another approach?
No, it's like I just want to say that without the stack, the question will be somewhat difficult, right?
Yes,
Yeah.
obviously.
Yeah. Since we are using the stack, the question became quite easier now.
Yes, ma'am. Yes.
Uh, this medium. Okay. Yeah. This is one of the problem. Implementing a stack using two queues. So in this problem, what they gave us is that they gave us two queues, and using this two queues, we want to implement and stack.
Okay. So like, so we have two queues. Suppose, um, okay. So push to. I mean, once explain the input again. Like, how did you give the input?
Yeah. So input is in this form. I will push. Suppose any element, I can do some operations. I can push the element or I can pop the element, and so basically what they are saying is, suppose I call this push function, the element should get pushed to the stack, and when I call this pop function, the element should get popped from the stack, but I should not use a stack data structure over here. I should use, rather than stack, two queues over here.
But okay. So like, what output is what do you say expecting? I mean, if you push two and push three, if it is a stack, if you push two, if you push three and again pop it, then it contain two, and if you push four again, it's two four, and if you pop it, it's two only. Okay, it's asking what all the elements which are not there. Is it?
No, actually, I think it will check what the elements on the stack are after each operation. So it will check the contents of this stack.
Okay.
It will basically, they are asking us to make a working stack using.
Okay. Okay. So we have to implement the stack data structure using the two queues.
Yes,
Okay.
yes, yes, yes.
Yeah, I understand. So
The approach may not be efficient. It can be any approach,
okay.
but I think it can be done in of 2n at least.
Yeah, because there are two queues. So yes.
Yeah. Mm, uh, any anything you thought of?
So, like, okay, so the first input is push 2, so we can, uh,
Maybe there is only one way to, which is similar to push, right? Insert way of this queue. So what we can do is
yes,
we
yes, brother.
can just add it to uh, first queue, right?
Yes, yes.
Uh, yes, and so what we will have now? We will have suppose first operation we will have a 2. In the second operation we will have a 3.
Yes,
And
2 and 3.
when we have to pop, then we will have to get
Yeah,
the
so it's like every time whenever the queue is full, okay, but we have to transfer it. So again,
so
it's
after the
yeah,
pop operation I will need to return 3 and not 2.
yes,
And since it is a queue, then I need to do something else on this.
but again, if we use the another queue, we can, like, if we want to send it to this Q2, like Q2 queue,
Okay.
we again just send it like 2 3 wise only, right? So
Okay.
what I was,
Then suppose I use the other queue and I just send the 2 to that queue, and now this q1 will have 3. Then I will
okay,
return
so
it with the
we'll
pop
send it
function is called.
as long as the last element is left, and then we delete it, and again we'll send it back to the Q1.
Yeah, yeah, exactly. Yeah,
Okay, understood. Yes, yes,
yeah,
understood.
yes. Yeah. So and this was stack using Tokyo's reversing first elements, print bracket elements we did. This also we did. Yeah, this one is also a good problem using the stacks. So in this problem, what they had asked is we are given an array, and we want the next greater element of that array. Uh, three is there, right? The next greater element will be 4. For 2 also the next greater element will be 4, and for 1 also the next greater element will be 3 and not 4, because just the greater element than 1 which is present on the right side, we want that element.
What we can do is by so we'll make it like a circular queue maybe, such that suppose I'll start with what is this element number one. I will pop this out like as a queue. It's a queue, right? So I'll pop this,
No,
and
no,
then
this is not a queue. We are given an array. We
oh, okay, I think we can transfer it to queue, right? I mean,
Okay, okay, we transferred it to queue. Okay,
so queue, if we transfer it, so like first I'll start with the element one. So
okay,
if you pop that out, the next highest will be 3, obviously. So we'll stop there. Uh,
okay.
I think my approach will be like O of n square maybe. So that's not efficient. 1 minute.
Yeah.
Uh, well, what else can we do?
This thing you can do without a queue also then, right? Just
Yes, obvious. That's what even I'm thinking. So that's not useful. So, mm, okay.
anything.
Uh,
uh, can we use stack over here?
But I mean, where we can use tag. Suppose like in this case, if suppose for the element three, the next highest element is not two. So, but how can we make it to remember like for the element three, the next one is four, right? So if we pushed it to a stack, then like if we traverse to the stack, how can we print the number four at the for the element three? That's what I'm thinking.
Uh, okay, another hint. Traverse from the backside.
You mean like push four first?
Yeah.
Okay, so obviously four doesn't have anything, so we'll put in another.
So
Can you another stack maybe?
4 doesn't have anything, so we will put -1 over here.
Yes, yes.
Then
So again, if we move to two, then well, the element two has four obvious. So okay, uh, but yeah, maybe it's like a dynamic problem. Maybe I mean dynamic programming problem. Like the four has nothing, it's -1, and two has the high next highest element is four, right? So
I
and
think yeah, this problem can be solved using DP also, but we can solve it using stack also.
okay, I mean okay. I will think by like using stack also one minute. So two,
Okay.
I mean
So can I give the solution?
yeah, yeah, sure.
Okay. So suppose 4 is there, right, and the stack is empty. Okay.
Okay,
Then we will make a new array of integer or maybe long variables, and what we will do at the last index, we will store -1. Then we will let me show the code only. So what we will do is we will go from the last element. If the stack is empty, then we will put -1 to the to this new array. Okay, and we will push that element to the stack.
okay,
And what we will do is suppose this 2 is there now. So
hmm.
while the element which is present at the top of the stack is lesser than or equal to 2, we will pop it out.
Okay,
So if there are many one present over here, right? So and there are many one present over here, and after that there was something, suppose 4. Then what we will do is when we see a 2, we will pop all that 4 till we find a element which is greater than 2.
in that case, isn't it again O of n square? Like I
uh,
mean, or not O of n square totally, but
no,
something.
because you are deleting many elements in the stack in between. It don't make O of n square. It comes out in O of n only.
Okay, okay, okay.
uh, how can I explain this to you? Mm,
Yeah, I mean, I understood your logic. Like, suppose for the second element two, so we have to like search for until four is occurred, right?
yeah.
And again for the element three, when we go again, we have to check for the element four. Like we have to traverse till element four,
Yeah.
and for the one, it's again three. So obviously, need not to again go till four. So
Yeah, suppose I will give other examples. Suppose the example is in this way. The starting element is 5, the middle element is 3, 2, mm, 4, and let's say 6. Okay, so then uh, first I will see a 6, then I will store -1 inside the array. Then Then after storing minus 1, I will see a 4, and I will see that 6 is greater than the element which is at the top of the stack is greater than 4. Then what I will do is I will store 6 over here. Then again 2 I will see, and I will see that the element which is present at the top of the stack 4 is greater than 2. Then I will store 4 over here.
Four only. Yes,
Okay.
and then okay.
Okay, now I see 3. Then what I will do is I will remove 2 from the stack, and since the next element 4 is greater than 3, I will print 4. Okay.
Okay, yes, but
Yeah. uh, Now when I encounter 5, uh, I will not need this 3, so I will pop it out. This 2 is already popped out. Yes. And the 4 will be popped out next time. So in a way what we are doing is the element which were popped out before, we are not looking at that elements next time, right?
yes, but
So what we are doing is we are just
we
making
are
a
not completely traversing till four
completely
because we
yes.
popped out two.
So
It obviously the four is okay.
if you look from the uh, array, if you look at the array, you are just traversing each element once while popping it out. So we are not making any overlapping many suppose we are not doing O of n square, we are doing O of n only, because we are going to the one element single time only.
Yes, I think at max it will be an n square by 2 whenever like it's whenever the last element is the largest and the remaining ones are increasing in ascending order. I think in that case
No,
also
I think at max it will be O of 2n, I guess.
yeah, O of 2 so not O of n square but yes O of 2 1
Yeah,
because yes understood.
because this 2 was we moved from this side, and when we saw 2, when we came to 3, we removed 2. So next time the 2 was not accessed only. So we in a way we are just moving from this side and that side to O of n and O of n times. So it is
Yes, yes,
O
okay.
of 2n times. Yeah.
O of 2 1 yes.
Yeah. So when I come to 5, then I will remove 3, 2 and 4, and I will print out 6. Yeah. So in this way we can access it. Yeah. So
Oh.
in this way we can get the next greater element in O of n time.
So basically, well, if we are popping it out, we are technically making sure that the like it's we are converting it to a DP problem there itself, right? If you pop it, like we
Yeah.
have to make sure the largest next largest element as it stays for the next ongoing element. I think okay, I think it's not DP, but anyways, understood,
Yeah,
understood,
yeah.
understood.
DP is somewhat very different. DP is used where we don't find any pattern, like everything is homogeneous. There is no greedy way uh, to do things. Mostly,
Okay.
the things are like a recursion. The things repeat from the beginning to start. Kind of that. This one don't come under DP.
Yeah, yes, I understood. So, okay, it's more a greedy approach. Yes,
Yeah,
because
it
at
is
that
more of a
instant,
greedy approach. Yeah. Hmm.
yeah. So at that instant, it's depending on the next highest. So as it is at that instant, I think it comes under greedy.
Yeah.
Yeah. Okay, but understood.
Yeah. So the other problems that include stack and queues are mostly the problems which also include other data structures like tree or maybe graphs. So at this point, I'm not including this, but stacks and queues are very important because we need to use them in graphs also, and in trees also.
Okay.
Yeah. Suppose I give you an example. Uh, Suppose this is an algorithm, level order traversal. So in this algorithm, what we need to do is we need to traverse through this tree. So how can we traverse through this tree? What we do is actually in a tree what we have is we have this left and this right pointer. Okay, so what we do for traversing level by level. So first I need to print this one, then 2 3, then 4 5, and whatever elements are present in this level, and then so on. So what I will do is I will print this one first. I will push this 2 and 3 to the queue. Then I will push the left and right of this also, and the left and right of this also. So and I will traverse, means like I will remove the elements from the queue one by one. So the order which I get the elements will be in a level order traversal. So one I will get first, then two, then three, then four, five, and so on. So there are many applications of stacks and queue.
Okay.
uh, there are other problems also, but they are like kind of more difficulty level, and we will cover them in the other session also. Like there will be one more session for stacks and queues.
Yeah, okay, bye.
Yeah. um, okay, so uh, hope you understood what is meant by stacks and queue.
Yeah, yes, understood. Thank you.
Yeah, yeah. Okay, then bye bye.
Yeah, bye bye.
Bye bye.